Okay, so we're rolling now. All right, so the question, it's going to say find the square roots of 25. I'm not a big fan of how they state this question, but this is the first type of problem you're going to get. When it writes it like that, they really need to, I want to translate on really what's being asked. It's being asked, what two numbers multiply to themselves to give 25? There's two answers. There are two numbers out there that if you multiply them by themselves, you get 25. So it's asking for what times what equals 25. Okay? That's the question it's asking. I don't care for how they write it, because typically if we say find the square root of a number, it means just give that positive answer. But there's two answers. All right? So can someone give us the answers to this question? 5 is one of the answers. That's not the, you gotta be careful, you gotta get both. So 5 times 5 is 25. What else? Negative 5 times negative 5 is 25. So when you answer this question, the answer is 5 and negative 5. Those are the square roots. Those are the two numbers that if you multiply them by themselves, you'll get 25. Okay. All right, got it? So, example 2, find the square roots of 81. So you'll separate your answers by a comma. You make, of course, one is positive, one is negative. All right, so what are the square roots of 81? 9 and negative 9. Okay? That's the answer. The issue I have is that technically square root symbol means that the answer is positive. So they have a different word if they mean just the square root. They'll say the principal square root. Okay? So it says find the principal square root. So if I give you example 3 here, if it says find the principal square root of 9, then it means this square root of 9. And the answer is just positive. So you only give a positive answer. Only give the positive answer. Okay. So for square root of 9, then we would just say what? 3, right? That's the answer. So do you understand the different wording? If it says give the square roots, and then notice it's plural, you'll give the positive number and the negative number. Okay. So what does square root mean anyways? What are we finding? What's the question that we're answering? Yeah, what multiplies by itself to give that number? Okay. So here, if it says principal square root, it just only wants the positive number. You don't give 3 and negative 3. Okay, that's the difference. Now cube root is a little different, so we'll do cube root, and then of course you could do 4th root and 5th root and so on. So we'll do cube root next. All right, and then we'll look at simplifying some problems. So, okay, can I erase the right half of the board? Do you have example 2 now? So I'll erase this. Okay, so now let's try cube root. So now, example 4 might be find the cube root of each number. Now, so now when we do cube roots, You don't have to worry about more than one answer. There's only one answer. Okay, because there's only one number, and I put a negative in here on purpose because I want you to know you can take the cube root of a negative. So this is asking what number multiplies by itself 3 times to give the inside. So notice there's only one number out there that can answer this question. So I want you to think about it. So do part A and then do part B. Okay. Figure out what's the cube root of -8 and figure out what's the cube root of 64. So you got to think in your head, what times what gives me -8? There should be only one number. And then what number itself times itself times itself gives 64. Okay. Okay. All right. So, Christian, right? Is that what you? Would you like to answer the first one? What number multiplies by itself 3 times? -2. That's exactly right. So if the inside is negative, your answer has to be negative. Does that make sense? Because you got to do a negative times a negative times a negative to get a negative. So it's okay to do the cube root of a negative, and the answer is -2. Why? Because if we do -2 times -2 times -2, we get -8. Okay. All right. Cube root of 64. What did you get, Hank? 4. 4 times 4 times 4 is 64. So this takes some time. I mean, maybe you got to do a little checking with the calculator or in your head. Or, I mean, of course, the calculator will do the cube root, but I'd rather you try to think through it. Okay. All right. So now the question is, how do I do this if it's with if there's variables with it? So like let's change gears now and just do a square root of a variable and a cube root of a variable and see how we would answer that. So now, let me erase this one. So let's go, any question what this is asking for? I'm hoping this is kind of a review, right? That's why it's a R6, it's supposed to be a review. Example 5, okay. Now, evaluate and simplify each square root. Okay, so now, let's say we have this, part 8, the square root of 16 x to the 4th y to the 8th. So how do I do this now when I have variables in there? So the question is, we got to think, how do I know what multiplies by itself to give x to the 4th? How do I know what multiplies by itself to give y to the 8th and so on? So the first rule is this: on square roots, if we have multiplication, you can take the square root of each part separately. You take the square root of 16, you can take the square root of x to the 4th, you can take the square root of y to the 8th. That's a property of square roots. So if you have a square root of multiplication, you can take the square root of each one. So the 16, hopefully that one's easy. We can knock that one out. What's the square root of 16? 4. You just give the 4. You don't do plus or minus because this is principal square root. What's the positive number? 4. Okay. Now, how are you going to do square root of x to the 4th? Can somebody give us the answer and maybe what thought process you went through? What's the answer for square root of x to the 4th? X squared. Would you like to tell us how you got x squared?
Since we're multiplying the 2x and x squared, we add a substitute.
That's right. So she's saying, basically she's thinking, what can I multiply to get x, what times what gives me x to the 4th? And she's right. What she's saying is, if we do x squared times x squared, you got to add exponents, and that's what gives you x to the 4th. So she went back and got x squared. I'm going to show you another way to think of it too in just a second, okay? So with that thinking, then the square root of y to the 8th you're asking yourself, y to the what times y to the what gives y to the 8th. It should be y to the 4th, okay? So another way to look at it is you're basically taking how much of the exponent? Half. That's exactly right. Because, believe it or not, square root means the same as raised to the 1/2 power. It means the same. It's synonymous. So if I look at it like this, if I have square root of 16 x to the 4th y to the 8th, I can write this as 16 x to the 4th y to the 8th to the 1/2 power. So these are synonymous. They mean the same thing. And then we have our rules of exponents, which we've had a lesson on, right? We had a whole lesson on rules of exponents. Do you recall that one? And we had a property. When you raise something to a power, you can raise each one of these to the 1/2. So you can do 16 to the 1/2, just like this line right here. See? X to the, times x to the 4th to the 1/2 times y to the 8th to the 1/2. So 16 to the 1/2, I think it's easier to do square root of 16, right? It's the same, this question and this question are the same. So we know that answer is 4. But look right here. Power raised to a power. What's the rule of exponents that says you do when you raise a power to a power? You multiply. 4 times 1/2 is 2. 8 times 1/2 is 4, and you get the same answer. Okay? So it's good to know that square root means to the 1/2 power. Okay, now, my question is this. What if I had a square root, but I couldn't take everything out? Let's just say maybe I had 9x to the 5th. Okay, let's say we had that. So the problem is what? Where's the issue on this problem? X to the 5th. You would rather it be x to a what power? A 4 or a 6, an even number, right? So what I would do here is this, is I would make this a multiplication and make x to the 5th, x to the 4th times x. So do you agree that x to the 4th times x is the same as x to the 5th? Yeah. And now, this one you can do, this one you just have to leave in the square root. So sometimes you can't take everything out of the square root. Okay? So we'll just do that. So see what is the square root of 9x to the 4th, but you leave the x in. So the one that you can take the square root of, it comes out, and you leave everything else in because x is not a perfect square. Okay? So essentially you're doing this and getting that answer, and you're leaving this one alone. That stays in because it's not a perfect square. So you just can't answer it. But this one you can do. Okay? You try to take the same approach. Okay, so what's the square root of 9x to the 4th? You would say 3x squared. So remember we said half the exponent, and then you would leave the x there. I don't think you'll get, most of them will be perfect squares. Okay, so you just will simplify. But that's how you do it if you can't take everything out. Okay, now while I'm on square root, I'm going to just address even root. So how would you work it? We'll call this part C. If you had the 4th root, let's say you had a to the 8th, b to the 12th. Now how would we work it? So what does 4th root mean? What multiplies by itself 4 times. But remember, if square root is 1/2 power, 4th root is the same as what? 1/4. So when we did square roots, we take half of the exponent. If you have 4th root, you could make it a to the 8th times b to the 12th raised to the 1/4. So I think it's easier if you change it to the 1/4, and then you can raise each of these power to a power. So then you can say a to the 8th to the 1/4, the 1/4 times b to the 12th to the 1/4. then if you multiply, it's gonna tell you what your answer is, okay? And it should be the same as what you were saying, is be something that we multiply by itself 4 times. So what is a to the 8th to the 1/4? A to the 2nd, and this is b to the 3rd. Maybe if you can go straight from here to here, that's fine. You don't have to do that, but I'm just showing you that it means the same thing as the 4th root. Okay. All right. Now, let's look at cube root. So we'll come over here and we'll do cube root. So let's say we had cube root of 27 x cubed y to the 9th. See if you can get that answer. Cube root of 27 x cubed y to the 9th. Cube root means what? What can you multiply by itself? 3 times. So what are you going to do to those exponents? You're going to basically take how much of it? A third of each exponent. Feels like a lawnmower, like right outside the door. All right, so let's go through this. Leah, what's the cube root of 27?
9.
9 times 9 times 9, does that give you 27?
Oh, no,
3. You gotta be careful, you did division, not exponent, right? So it's 3. Cube root of x cubed. X, right? Because cube root was, what is it asking? What times what times what? It gives you x cubed. It's gotta be x times x times x. Everybody with me on the cube root of x cubed? The other way you can look at it is x cubed to the what power? Cube root is the same as to the 1/3, and notice it will cancel, just gives you x. So what's the cube root of y to the 9th? Y to the 3rd. So again, how am I getting that? Because y cubed times y cubed times y cubed is y to the 9th. Or I can make it y to the 9th to the 1/3. Cube root means 1/3 power. Those are synonymous. Okay? All right. Okay, so this is the answer. All right. So basically, whatever root it is, what are you doing to your powers? If it's square root, here's 4th root. Look at our exponents and look at the answer. So it was 4th root, what happened to our exponents? They're how much? 1/4 as much. If it's cube root, look at our exponents. They're how much? 1/3, okay? So technically, this was 3 cubed, and now we're at 3 to the 1st, a third. That's what 27 is, it's 3 times 3 times 3, okay? Any question about square roots or cube roots with the numbers and variables? You're gonna practice these, right? As we sit here and we go through it, we can look at them, okay? So when we go into so basically what we do is we finish early. If you have a laptop, we'll go ahead and get into my math hub. If not, we just go across the hall, bring a laptop here and we'll work. And then you can just bring it back and we can look at the problem. Okay, so what's rational exponent? Well, I've kind of already introduced that a little bit. So one thing to understand is that if we understand that square root is the same as 1/2, that's a rational exponent, a fraction exponent. Cube root is the same as 1/3. 4th same as 1/4, and so on. So from there on, you got the idea. So if it's fifth root, it's the same as 1/5. So they may give me a problem that says write it as a radical or write it with the exponent. Okay. So here's a question that we might get is something like this. All right, we'll call this, I think I'm at example 5 maybe. Rewrite, example 6, thank you. Rewrite as a radical expression. Okay, so let's try this one, part A, 7 to the 1/2. So now I give you a rational exponent, can you make it a radical? Okay, so I've given you the fraction exponent, can you make it as a radical? So that's a square root or a cube root or whatever. So how do you write that? And what does that mean? So you need to have a square root symbol or a cube root symbol in your answer. You don't have to get a number answer, you just have to rewrite it. What's the other way to write it? Just do that and then we'll ask. Yeah, so it's just what? Okay. So you say square root of 7. Yeah, square root, cube root, fourth root, fifth root. That's it. Because I can't really give a decimal. I mean, I could, but they just want you to rewrite it so you understand those equivalencies. Now here's where it gets a little weird. Okay, let's say I had 2 to the negative 1/3. So, question. This is supposed to be your negative exponent. I know those are your favorite. So you can't replace these if you have a negative exponent. So the only way you can make a cube root is if you have a positive 1/3, not a negative 1/3. So when I get this and it's asked me to put it back as a radical, I got to get rid of the negative. So the question is, well, how do I make that a positive 1/3? So now you got to go back to your rules of exponents. So one of your rules of exponents says, if I have a to the negative m, it's 1 over a to the m. So I can change its location in the fraction to make it positive. So that's got to be my first step. So the first step is I got to make that a positive exponent, then I can substitute in the symbol. Okay? So I'll make this what? Or you guys go ahead and see how far you can get. And then once you get a positive exponent, then you can substitute the radical back in. Okay? Think you got it? We'll check. Okay. So the first thing I can do, Allison, is write it how? How can I write this? 1 over 2 to the 1/3. And it just wants me to have a radical, not a fraction. And now I know 2 to the 1/3 is the same thing as what? But you'll have to make it 1 over cube root of 2. And there's buttons into my math, like you'll pick the fraction button, and then they actually have a button like this. It'll have like a blank, a square root, and a blank. You'll click that button and you'll put the 3 there and then the number there. It's not a square root, but it's a round. Okay? And that's your answer. Does that make sense how I rewrote that one? Okay? Let's try another one. For this question, we'll just do one more like this. Let's just say we have 5 to the negative 1/4. Just write that as a radical. One more and then I'll move on to the next. this one will be a two-parter. Rewrite as a radical and simplify. Okay. So same idea on this one. We'll first make it what? 1 over what? Yeah, 5 to the 1/4. That's not a radical, that's a rational exponent. We need a radical. So to make it a radical, we'll make it 1 over the 4th root of 5. That's the answer. Now, look at question 7. What's the issue with the question on number 7? Anybody notice? Yeah, it's not 1 over, it's 3 over. Okay? Does everybody understand? I have to have 1/2 to make it a square root. It's 3/2. So the first thing I want you to understand is, what does to the 3/2 mean? It means this. This means 9 cubed to the 1/2. How do I know that? Well, I'm basically using power to a power in reverse. Because a power to a power I multiply. So I know 9 cubed to the 1/2 should be this, and equal signs, you can travel both ways on an equal sign. So I split it up and I made it 9 cubed to the 1/2. And then once I do that, then I can write it as a square root. Okay? So then I could make it square root of 9 cubed, and then the question is, could I get an answer? You know, is that something you could get an answer to? It's not gonna be that pretty, but I think it's like 81. Wait, what is it? This is square root of 9 cubed. Should be like 27, I think. The answer should be 27. Yeah. How did I get that? Well, all I did was this. This is the square root of 9 times 9 times 9. What's the square root of each one? 3. So it's 3 times 3 times 3, which is 27.
So is 27 the answer?
Should be. It's going to ask you to simplify 27. It'll say, it'll be 2 parts is what I'm saying. Write it as a radical. I did, then find the answer. Okay. Okay. What else? All right, see if you can do this one. 4 to the 3/2. Write it as a radical, then write the answer. Okay. So first thing I can do is write it 4 cubed to the 1/2, right? Everybody good with that? And then, now if I write it as a radical, that's a square root of 4 cubed. And you got a couple ways you could do this. So this is like the first part of the checkpoint. Here's your radical. The second part is you just got to get the answer. Well, 4 cubed is what number? What's 4 times 4 times 4? 64. So what's the square root of 64? 8. That's the answer. Okay. All right. Couple other problems. Then we'll turn you loose on the work. How would you do this one? If you had to simplify, what do you think you would do first? These are kind of a pain. If I said simplify this as much as possible, what do you think you would do first? What's that? Yeah, you have to add the x, so Allison's exactly right. When the base is the same, this means that you have to do 4 to the 1/2 plus 2/3. But the problem is, those are fractions. So you're gonna have to add those fractions up to get the new exponent. Well, how do you add fractions? Rhymes with renominator. Find a common denominator. You like my rhyming skills? Okay. You gotta get a common denominator. So what's the common denominator for 2 and 3? The lowest common multiple is what? 6. So then you're gonna have to go ahead. So we did our rule there. This is a to the m times a to the n. We gotta add, and then we're gonna have to simplify this as much as we can, because that looks awful, right? We don't want to say 1/2 plus 2/3. So then we'll get a common denominator. If you want to do the work to the side, the 1/2 and 2/3. So I'm going to multiply this guy by 3 over 3 and this guy by 2 over 2. And so what do you end up getting? 4 to the what? 7 over 6. So now you've made it and you've simplified there. If I wanted to write it as a radical, what would it look like? What's the radical for this? The 6th root of 4 to the 7th. That's exactly right. Okay. Very good. All right. So there's the fraction. There's the exponent. Those are synonymous. That's a rational exponent because it's got fraction. That's a radical expression. Those are the difference. Okay. So if you have multiplication or you have division, you have to use those rules accordingly. Okay. All right. 2 more problems left. Let's talk about the best way to do these and then we'll stop there. What if I had this part B. What if I had x to the 4th over y to the 12th to the negative 1/2? You got to really dig down onto your rules. So I have a fraction, but I have this negative exponent. Always get rid of negative exponents first. How do I get rid of when I have a fraction to a negative exponent? That was one of your rules. Your rule is if you have a over b to the negative m, you can make it blank to the m. That's one of your rules of exponents. Who knows? It's in, I mean, it should be in your notes, like rule 9 maybe. This rule will come in here.
Oh, it's you flip, it would be b over a with a positive
That's
exponent.
exactly right. So always my goal is to get rid of the negative exponent first. So all I'll do is make this y to the 12th over x to the 4th to the 1/2, and then you just put the 1/2 to both of these. Okay, so you can flip and make it positive. So if you have a fraction to a negative exponent, flip it, make it positive. I'm just trying to go through all your scenarios. And so then it's y to the 12th to the 1/2 over x to the 4th to the 1/2. And you should get your answers from there. And 1/2 means the same as what radical? Square root squared. Okay. So if you have a negative exponent, you can flip and make it positive. All right, because I can't start to do, I don't want to distribute a negative exponent. And what would my final answer be? Y to the,
Well,
no, it is 12. 12 to the 1/2 power is what? Anybody? Y to the 6? X to the 4th to the 1/2 power is x to the 2. Square roots. What we've been doing. So, rational exponents are what exponents? Exponents that are fractions. Always get rid of what exponent first?
negative.
Negatives. Make it positive. And then you know your equivalency. Square root is the same as what power? 1/2. Cube root is the same as what power?
1/3.
So if I had, say I had 1/2 to the negative 1/3, I can make that 2 to the, yeah, it is 2 to the 1/3, right? You can change its location to make it positive. You can change its location in a fraction to make it positive. What would you think, right now we've already referred to it about 3 times, what should you have handy as you do this problem, other than these notes?
Your,
10 laws of exponents. That's exactly right.
your toolbox.
Your toolbox, that's exactly right. Because if a radical is an exponent, then do you need your laws of exponents? Yes, yes. You will come back to it and you'll ask, okay? All right, so we'll stop there. We'll let you work through these. If you get stuck, bring the problem to me, okay? And we'll look at it on the computer. All right, so I'm gonna stop it there so I can upload this. So for everybody at home, good luck.